ellipse, que es closed figure, but is, you know, different distance, no? So the horizontal, we discuss in different scenarios, but basically the elementary idea is that we have a closed curve que is no equidistant to the center. Center is here, center is here, and the circle, of course, equidistant in any direction in this case. A hyperbola contains two branches, like that, or another way. This is, okay, you see that we have one branch here, another branch here. Okay, parabolas here is also open, no, not closed. And circle and ellipse, yes, it's closed. Okay, another idea is this. Okay, look, this is the circle, ellipse. We have two kinds. In a few minutes, we see the two kinds of ellipse. Hyperbola, you have two kinds. And parabola, we have four kinds of parabola. But the important thing you need to know, circle and ellipse are closed figure, and hyperbola have two branches, and parabola only one. Okay, let's move on directly to ellipse. Let me try to find another. I send the PowerPoint, no? Do you see I send the PowerPoint? I send also the link connecting to Desmos is the script that we are using. For example, look at that. Elixir, guys, when you are doing the graph of the elixir, you need to describe perfectly in detail different points. For example, the most important point is the center. The center. And we have two vertices, and plural vertices. Okay, this is the vertex. This is another vertex. The vertex is located in the same line of the major axis. Major axis, you know, elixir is like that. This is the center. We have major axis here, and we have minor axis here. Okay, so now the vertex is located in the direction in the same segment of the major axis. Another co-vertex, or not exactly, another name is endpoint of the minor axis. It's okay, it's this and this. And we have a focus, in plural is foci. We have two foci. The foci lie exactly on the major axis. Because we have different distance to study in detail. That distance is A. Normally it's called A. That distance is B. So this is actually the name of this is semi-major axis, because the total major axis to A and the total minor axis to B, no? Those are the sum, que is a half, is A and B. And the focal distance is C. Actually, the big distance is A always. So A is the big distance. And the mathematical relationship in between A and B and C is que A squared is equal B squared plus C squared. It doesn't matter si es in horizontal direction or in vertical direction. Okay, so the most important is the point. Point is center. Let me copy. Important point. Important points. Center. vertex 2. Call vertex, but I don't like this word. You call endpoint. Endpoints of minor axis. Es too long, pero more clear. Fuzzy. You have to. And the distance associated with that vertex is associated A, endpoint minor B, and the fuzzy is C. Of course, that distance is measured from the center. Okay. However, to understand much better the ellipse, before start example, of course, I need to present to you the two kinds of ellipses we can find. The two kinds of ellipses we can find. Look, we have two. Why two? Because depending the position of the major axis. See, the position of the major axis is parallel or coincident with the x-axis. This is horizontal. Repeat again the idea. Horizontal what? Horizontal ellipse. See, the vertex or major axis is coincident or parallel with the x-axis. Therefore, is the horizontal. However, see, the major axis is coincident or parallel to the y-axis, is vertical. Vertical ellipse. And this is parallel or coincident with the y-axis. How do you know that? How do you know that? Well, because in the equation, this is the equation, this is the most important you need to remember. We have the standard form of the equation for the ellipse is, you know, look, suppose the blue equation, I want to copy again. X minus h squared over a squared plus y minus k squared over b squared equal 1. Okay, in the standard, you need to guarantee that the right-hand side always is 1. Right-hand side must be 1 in the standard. So you will need to write. Now, all we having some problem is given the equation completely disorganized. I want to teach how you organize it, putting a standard to analyze. Now, remember, A is the distance on the major axis is, you know, coincident with the x. That is the reason we are talking about horizontal axis, horizontal ellipsis. Sorry. Likewise, the A is located in the y part like that. X minus h squared over b squared plus, always plus, y minus k squared over a squared equal 1. Entonces now A is associated with the y. Therefore, we are talking about vertical ellipse. How do you know who is A and who is B? The problem is that A is the bigger number. Always, 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 A is the bigger number. When you take the equation and you see, what is the big? The big is this. This is A, and the smaller is B. That is the reason. And now, so you see that the big number is A associated with the X, my ellipse look like that. If the A is associated with the Y, my ellipse look like that. Very cool. Everyone follow me? It's easy. Okay, of course, I want to complicate a lot of this. So now the first thing you should do is manipulate the equation that is given and express it in standard. When the equation is expressed in standard, you identification. Oh, I forgot to say something important. And the center is the point h, comma k. So you see here h and k. Look, h and k. It's the center. Sometimes happen one problem that you have no. For example, the example one that we are discussing now is like that: x squared over 16 plus y squared over 9 equal 1. Wow, easy. It's already expressed in standard. Nice. Okay, now it's obvious que the center for this elixir is located at the point 0,0. Because I don't see any subtracting something here, h and k, no? Like that. This is the general equation for the any point center. However, it's very frequently see example in which the center is located at the point 0, 0. Entonces, the equation is reduced like that: x squared over a squared plus y squared over b squared, or x squared over b squared plus y squared over b squared, a squared, sorry, equal 1. Okay, one more time. This is this, and this is that. But the only difference between this is that this center, is located at the point 0, 0. Cool? Okay, so now, for the moment, it's okay, theoretical part of the ellipse. I promise that we are doing 1, 2, 3, 4 example. Now, immediately, we are doing, we discussing the theoretical part of the parabola and the hyperbola, little by little, no? Entonces, I want to erase the board. I want to face doing the example one. The example one is x squared over 16 plus y squared over 9 equal 1. Cool. Entonces now immediately I recognize que es same format for the ellipse. I determine that a squared is 16, then a for 4, square root, and b squared is 9, therefore b is 3. It's obvious that the center is located at the point 0, 0 because I don't see any shift, horizontal or vertical, in x or y direction. No. Then the c value is equal to s square root a squared minus b squared. This is the formula, no? Okay, you can find in the same formula I explained at the beginning, no? Okay, a squared is equal b squared plus c squared. So you isolate the c, you move with subtraction b, apply square root both sides. In this case, is 16 minus 9, okay, 7 is radical 7. Sometimes happen that we have irrational solution, but you put 2.65 gets the decimal approximation. Okay, with this information, we are ready to do the sketch of this. Okay, let me try exactly here. Let me see, I don't remember very well where is the rectangular coordinate system. It's supposed to be here. Oh, over there. Rectangular coordinate system. Of course, we are doing decimals. I'm doing more than this. I create a script in decimal, and you using this script. I sent to you the link. You can open. Remember, this is a copy of my work. You can do everything on this, no problem, because my copy stays safe. So you can delete equation, you can destroy everything, no problem. No problem. Okay, the center of the our elixir is located at the point 0, 0. Here is the center. Let me plot the point. Entonces, I know que this is horizontal elixir, yes or no? Because major axis I, que is the big number associated with the x, and AF4. So we have 1 point here and 1 point here, que es 4,0, and negative 4,0, que is the vertex. And the vertex of the our elixir is 4,0 and negative 4,0. Likewise, the endpoint of minor axis lie on the y-axis in this specific example, or no, of course, and the distance is 3. 3 up and 3 down. At that point is the point 0,3, and that point is the point 0,-3. Okay, so I have more idea, a little bit, how look like our elixir look like that. The problem I want to do in Desmo right now, elegant. And the endpoint are 0,3 and 0,-3. One more information we need. When we need the foci. The foci is located at the distance 2.65. 2.65. Let me use another color for the foci. 2.65, 2.65, approximately here. This is the foci 1. Okay, is, 2.65 or whatever you want to call radical 7,0. And the foci 2 is 2.61, approximately the same distance. This is C distance. Here is minus radical 7,0. End the story. Okay, entonces de foci en plural. Foci is the plural of focus. Focus is only one, foci 2 or 7. Is radical 7,0 and minus radical 7,0. That's it. We finish. Do you understand very well or not? Just I forgot center here, 0, 0, is the center. Okay, how we are working in the Desmos. You don't need to do anything, only pay attention. Look, let me try. Okay, there you go. Conic Sections is the name of this script that I create for my students. Look. Do you see Desmos? Okay, cool. Now, look at that. I have this example, 1 here. X squared over 16 plus y squared over 9 equal 1. Oh, nice, in the standard. I do the graph of this, true. But to complete this with a point and something, I create a script in which you define A is 4. Let me try to use my keyboard. You type in here 4 or just the slider. But in this case, much better for me is typing 4 and 3, no? And H and K, que is the component of the center, 3, no? What's going on? 3. Okay, the component for the center is 0, 0, so we have no component 0, 0, 0, 0h, and 0k. That means our center is located at the origin point. Okay, P is another thing we're studying the parabola, but P I don't care now. Now I classify like a horizontal ellipse, right? And you click here using this parameter I adjust here, and we get this answer. Look, 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 look. This is the center. This is the vertex endpoint of the minor axis and fossil. End the story. Okay, so I would like you take advantage of this script for any conic section that we have studied so far. Okay. Question? Nothing? Comment. No comment. No comment means you understand very well, no? If you want, no, not necessarily now. You open the Desmos, you click in the link I sent to you, and you open Desmos and you imitate my work. Okay? Let's come back. Come back. No, not come back. Let me take advantage. We are in Desmos to see what is the example number 2. Okay, example number 2 is, okay, let me here and here. Put on enable. Now here, example 2 ellipse is this. Ooh, 25x squared plus 9y squared equal 225. Ooh, what the hell? Let me come back to the whiteboard to understand this problem. Okay. Do you see my whiteboard? I suppose you see, right? Yes or no? Jenny. Bueno, entonces the second example, Jenny, is $25 x squared plus 9 y squared equal 225. Oh, this equation is not any standard. I need to change to a standard. Now remember, standard is when the right hand side must be 1. Must be 1. So you divide by 225 everything. Entonces I put in my calculator 225 divided by 25 is 9. Pero 9 in the denominator, ¿no? Plus. And 225 divided by 9 is 25. Y squared. And this is 1. Wow, nice. This is now already in standard. My question, who is A and who is B? Or who is A squared and who is B squared? Who is A squared and who is B squared? Help me. Say something. No idea? Okay, A squared is 9 plus 3. 9 plus 3, I don't understand. So A squared. So we have to.
Sorry, Professor, I meant 9 and then equals 3.
Oh, yeah. I understand. So A squared, you say is? Who is A squared for you?
It's 9, the denominator of the first one, and then once you do the square root, then it's 3.
No. This is wrong. Look, you need to understand that A squared is always the big number. I put intentionally. This is 25. Okay, the selection, who is A and who is B, depending. No, no, it's okay, Jenny, it's okay. Okay, therefore, you are doing your best, I know. F5. Okay, and B squared is 9, therefore B is 3. Entonces now, okay, what is my next question? My next question is, this ellipse is like that or like that? Is horizontal or is vertical? And why? Es horizontal. Edward say es horizontal. Everyone is agree que es horizontal? Edward Reyes say que es horizontal. No, es vertical. Why? Okay, pay attention. A is the major axis. And major que es phi, que es associated with the 25, que es square, is associated with the y. Therefore, the major axis lies on the y-axis. Do you understand, Edward? Edward? Okay. Okay, this is a detail, I know, but you need to know that. Okay, so the center, yes. The center, one more time, is located at the point 0, 0. Because I don't see any H, any K, no subtracting, no addition, anything, no. No, no, therefore 0, 0. No, no horizontal shift, no vertical shift. Okay, what about one more information we need? We need one of the vertex, I suppose that the vertex is located here, look, here and here. This is my vertex. And that distance is phi. Phi and phi in both directions. Therefore, that point would be 0,5 and 0,-5. Are you agree or disagree? That the vertex, okay, the vertex, guy, is the point in which the ellipse, okay, the curve crosses the axis, no? Maybe y or maybe x. In this case, y, because I know that the major axis lies on the y-axis. And the vertex is located at the point 0,5 and 0,-5. So phi is the distance from the center is here. Okay, what about that point? And that point is the end point of the a minor axis. What do you think? Is this, and this distance is 3. And the distance is 3 because of B. Look, at that point R 3,0 and minus 3,0. Makes sense, eh? Okay. Now what about foci? The foci is located in. You need to find the focal distance. Focal distance is C. Focal distance is C, and the formula is C square root A squared minus B squared. And the square root A is 25. Minus 9 is 16. And the square root 16 is 4. Okay, that distance is 4. That distance, let me use another column. 4. And this is the foci. Foci 1 and 2. And this distance is 4. Therefore, the foci is located at the point on the y-axis, entonces 0,-4 and 0,+4. The order is not important. You indicate the order that you want. This is clear or confusing? But let me verify using my script and Desmond, okay, everything is okay or not. Okay, so in any problem, I switch into Desmond verification. Nice. We will continue. You have question? Do you understand the idea? Do you understand how we investigate the conic section? So now, this is just the beginning. I want to complicate it with the parabola or hyperbola. So you need to identify what is the clue que give me identification. And inside the elixir, we have two possibilities, horizontal or vertical. And you see who is A and who is B. And what A is always the big number, and the big number in this case is associated with the Y. Therefore, we are talking about vertical, vertical ellipse. Okay, so when I plot in Desmos, let me share the screen. Look, I plot in Desmos, carajo, here. When I select example, do you see Desmos or not yet? No?
I can see it.
Yeah, cool. Okay, I put non-standard, I put in the given form. Because Desmos is fantastic. Desmos knows very well algebra. Entonces now I plot that. However, I want to verification and also plot the important point, no? Entonces, in the verification, I understand que C es phi, and B is 3, so I don't touch. And the center es lo que es en the 0, 0, no problema. And identification that we are talking about vertical ellipse. Boom, look at that. It says center, this is vertex, 0,5, 0,-5, endpoint of the minor axis, 3,0 minus 3,0, and the foci is located at the point 0,4 and 0,-4. Boom, end the story. End the story. We are using, let me see, one segment in red color for the major axis and green color for the, I don't know if you see very well the line, you know, for the minor axis. Cool? We're doing well. Everyone follow me? Everyone understand very well or no? Confusing? Or clear? Okay, let's move into example 3. I want to present to you in Desmos. And after we manipulate something in the piece of paper, in the whiteboard. Example 3 is this. X minus 3 squared over 16 plus y plus 2 squared over 25 equal 1. Okay, let me enable this. Okay, I want to copy this in my whiteboard. Do you see my whiteboard? Glad you always help me. Example 3. Well, example 3 look like a little bit more complicated because it's x minus 3 a squared over 16 plus y plus 2 a squared over 25 equal 1. Oh, nice. This is already expressed in standard. Then I want to determine who is A and who is B. Who is A and who is B? Or who is A squared and B squared? Because to find A and B is super easy. Find the square root. That's it. Who is A squared? $25. Always the big number. Of course, B squared is 16. Now, automatically, I determine A is 5 and B is 4. Entonces es obvio que dice elixir again es vertical elixir. Yes or no? Porque that distance is 5 and that distance is 4. And what about the center? Oh, in this case, no 0, 0, because I see minus 3 and plus 2. Okay, and remember, very, very similar to the thinking we are doing in circle. When you study circle, is, you know, the center is located, she compare this equation and my general equation. Let me copy my standard general, no? X minus h squared over, in this case, b squared, no? Plus y minus k squared over a squared equal 1, no? Or identification, a squared 25, b squared 16, but h is 3, look. However, k is negative 2. Do you see or no? Do you see or no? It's opposite sign. So the sign that you see in the equation when you are doing the graphic is completely opposite. Okay. Now, the only thing I need to know is find the C. C, que is the focal distance, is square root 25 minus 16. Okay, es a square minus b square. Radical 9, que es 3. Entonces, the foci is located 3 distance from the center. Okay, it's 3 distant. I suppose we're using another color. From the center, 3 distant in the same direction. This is the focus. Okay, here. The distance is 3, 3. Do you follow me? So now we need to determine the point. What point? Vertex 1, vertex 2, endpoint minor 1, endpoint minor 2, that point foci 1, foci 2. I call 1 and 2 because I want, no, you call different 1 and 2, 2 and 1, doesn't matter. Okay, so of course we are using this software, the script in Desmos, to determine the component, no, of the any point. Let me try. Here, over there. Cool. I suppose you see Desmos, right? Or no? Okay. Look, this is the example we are doing, example 3. Boom. Oh. Yes, look like vertical. Remember, vertical is when the distance in the y direction is bigger than the distance in the x direction. To determine the point, you assume okay, AF5 and BF4, correct? BF4. And the H and K are 3, 3, 3, 3, 3, H is 3. And K is negative 2. Negative. And we are talking about the vertical ellipse, no? Yeah. Boom. Look at that. The script have inside the specific equation that you need. You can do by hand. This is no big deal. But to save time in this stupid arithmetic, because it's just I create for my student, of course, this script. So now, conclusion, the center is located in the 3, -2, exactly we expect. The vertex located 3, 3 and 3, 7. Let me check it just in case, because the distance is 5, no? The distance is 5, A is 5. Entonces es, you go over 5 units, -2 plus 5 is +3. And -2 minus 5 is -7. Makes sense, right? Look. In that direction, the B is 3. Entonces es 3, pero you increasing or decreasing the first component. Entonces 3 es 4, sorry. 3 plus 4 is 7, and 3 minus 4 is -1. And again, up and down, the focal distance is 3. Entonces, negative 2 plus 3 is positive 1, because when you're moving upward or you're moving downward, you addition or subtracting the second component, the y component, because the motion is vertical. When you're moving horizontal, no. You add addition or subtraction, the first component, que es x. Entonces, negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. Boom, end the story. Easy, easy, super easy. Do you see or no? No? Confusion? Yes. Clara dice yes. Okay. It is clear the example 3. Let's move on to the example 4. Example 4 is a little bit more complicated. Let me explain why. Why? Because example 4, no? Yeah. Look, ooh, what the hell is that? 3x squared plus 7y squared plus 6x minus 28 plus 10 equal to 0. It's not expressed definitely in standard. But you need to apply some algebra first. I see decimal. Yeah, I know. I know that you see still decimals. This is the thing I want to illustrate. This is the formula I want to manipulate in the whiteboard, correct? Okay, by the way, I believe que es elixir, no? Elixir, because what is the glue? Give me information. Let me explain in detail. Let me switch into the whiteboard. Whiteboard. Let me delete. Example 4. Example 4. Example 4, que is the typical question in the test. I never put elementary example, I put a complicated example. It's given in that way. Now that way in which the right hand side is 0, let's call it right hand side is 0. Let's call it general form. But the general form, you don't see anything. I don't see center, I don't see foci, I don't see anything. They need to manipulate. How you manipulate? Easy. You take, for example, the x part. The term can contain x, and the term can contain y, and you separate. You separate like that. 3x squared plus 6x together. But much better is you factor out the numerical part 3. You factor out, you see that 3 is common factor. So you factor out. You put a 3 outside. And you have x squared plus 2x, because 2 times 3 is 6. Plus, you complete the square. This is the organization. Likewise, we are doing in the y part. You put a 7 outside. So we have y squared minus 4y plus another box. Okay, help me to complete the square in the y part. Is equal minus 10. Okay, move a 10 to the right hand side plus 2 boxes. And inside the box, you put a number. Okay, you artificially create to complete the square. So we all remember the formula for the complete square as b over 2 square, no? I suppose you remember that. 2 is divided by 2 is 1 square 1. This is 1 here. And here 4 divided by 2 is 2 square 4. Do you remember that or no? Yes or no? Or I need to explain clear, more clear. Tell me something. Yes or no? Explain. Okay. So do you remember completed square? Completed square is, suppose we have one trinomial, x squared plus 2x, but you create a trinomial, and this trinomial must be perfect square trinomial. And perfect square trinomial is, you know, for example, is the factorization perfect square is two twin brother binomial, exactly the same. Okay, you can write definitely like x plus 1 squared. Okay, so now, if you introduce here one number here, 1, where come from this 1? You take 2, get b, divided by 2 squared. This is a formula. 2 divided by 2, you take b. b is 2, it's obvious, no? Divided by 2 is 1, and 1 squared is 1. And this one you put it here. And when you put it here, the factorization is this. Okay? It's clear or it's confusing? Likewise, and the y part, b is 4. I don't care the sign. The sign is not important. Divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. Oh, it's a coincidence. Okay, 4 and 4. And the factorization would be, I suppose, y minus 2 squared. Do you understand the importance of this? Okay, cool. Then the factorization, that part would be 3 parentheses x plus 1 squared. Yes, plus because this sign is plus. Because the second sign is always positive. You add it, never subtraction. Plus 7 y minus, because this sign is negative 2. Where I come from 2, square root 4. Now, the most important detail. In the right hand side, I put 2 boxes que not necessarily is equal 1 and 4. Because you have a multiplier in front, get 3. Actually, when you introduce artificially 1, 1 here, definitely in the left hand side you introduce a 3. Because 1 times 3 is 3. And 4 times 7 is 28. Now you combine. This is 20, 20, 20. Well, is 28 plus 3 is 30, 31, 21, because 28 plus 10 is 31, no? Minus 10 is 21. It's 21. Do you see? We almost finished. To be in standard, I need that the right hand side must be 1. Therefore, you divide by 21 whole thing. 21, 21, 21, and 21. And 21 divided by 3 is 7, but 7 in the denominator, entonces x plus 1 squared over 7 plus y minus 2 squared over 3, que es 21 divided by 7, and 21 divided by 1 and 1. Nice. This is my equation expressed in standard. Unbelievable. In standard form. Unbelievable. This expression is equivalent 100% equivalent. I want to prove now with the ugly original equation. Okay, nobody understand. However, I can see clear like water now. A squared is 7 and b squared is 3. Therefore, a alone is radical 7, Okay, you want to have idea is in decimal approximation is 2.65. And B is the square root 3, que es approximately 1.73. Es obvio que this ellipse is horizontal, no? Because the center, by the way, I don't found center, pero no now, that distance I discover que es radical 7. And that distance I discover que es radical 3. Therefore, the horizontal distance is bigger than is horizontal ellipse. And the center is located at the point -1, positive 2. It's this number with the opposite sign and this number with the opposite sign. And that's it. Well, no, because I need the foci. The foci is located here. Always foci is located in the major axis. I need to find that distance is C. And C distance is square root A squared minus B squared. Entonces es square root 7 minus 3 que es 4. And square root 4 is 2. Okay, entonces that distance is 2. Entonces from this point you move in 2 in this direction and 2 in the opposite direction. And you get the foci. Cool? Of course, we are doing using decimals because it's easier. Huh? Do you understand very well the process, the procedure for the completed square? We practice. We have more example of this. I don't know if it's example 5 or not. This is example 4, no? Yeah. Okay, let's do it in decimals now. There you go. Okay, this is example 4. Example 5. Okay, let's do it right now. Example 4. Example 4 is, let me put on the table. Oh, look at that. It's a horizontal ellipse. And do you remember A is radical 7, which A is radical 7. You put it here radical 7, but I recommend using the keyboard of decimals, que es fantastic. You delete that. No, totally, no. The only part you put radical 7. Radical 7. 2.65 approximately. 64.5. And likewise, we are using B. You delete that and you put radical 3. No? 3. Excellent. Now, H and K. H is the component for the vertex is -1. H is -1. Okay, -1 is in opposite direction, -1. And K is +2, opposite direction, +2. Cool, +2. Okay, ready. Entonces, your identification that we are talking about the horizontal ellipse, no? Yeah. Boom. And we get the points. Look. Center, -1,2. This is magic, guys. There are a lot of mathematics behind this idea. Sammy major axis was 2 point something in this direction, 2 point something in this direction. And Sammy minor axis 1.73 in that direction, 1.73 in that direction. And the focal distance was 2, it's easy. Entonces 2 in that direction, entonces -1 plus 2 es +1. And -1 minus 2 is -3. And this is our ellipse. Okay. Curiosity. Well, no curiosity. So actually, the mathematical behind this is using the standard. So they are a perfect equivalence between the general, que nobody understand, and the and the and the and the standard. No, guys, you follow me on totally lost. Let me know. True. I know this is no big deal. It's not hard. Yeah. Okay, Jenny. But you know, there are a lot of detail, no? Okay, let's move on to parabola. Let me try to spend the time. I promise que, yeah, I promise que, and the review back, maybe we are doing more example of this. Okay, cool. Let's go to the parabola now. Parabola. I want to come back to the whiteboard. Okay, whiteboard parabola. Parabola. Do you see my whiteboard? Yes or no? Okay. Parabola. Entonces, parábola, guys, is a closed no, is open. So parabola. We have two kinds of parabola. Parabola at a horizontal H, and parabola vertical also. Vertical and horizontal. And inside the horizontal we have two kinds. Okay. The formula for the parabola is, you know, y squared equal 4p. I want to explain tell who is p after. Y squared equal 4px. When the parabola, when the equation look like that, the parabola open in that direction. Open to the right. A horizontal and open to the right. When the y is square and x is not square. Do you see? It's important that so far you see the difference. When you see conic section like that, x squared plus y squared, and here one number 5, 20. This is the mix. However, if you see x squared and y no square, or x no square and y square is a parabola. Okay, entonces now, in this case, it's to the right if p is positive. But the if p is negative, the parabola open to the left. Okay. Now, how do you know vertical? Well, vertical is similar, except the formula is different. It's x squared equal 4py. You know, in the horizontal, y is square and x no square. And the vertical, x is square and y is no square. Entonces the parabola open depende, ¿no? Si p es positive o p es negative. Si p es positive, open up. Si p is negative, open down. This first approach is okay? When you face one problem, you need to recognize, it's parabola, okay. What kind? Horizontal or vertical? In what direction open? Right, left, up, down. That depends on the P. P is the control of this. Okay, now that's it, no? Several details. Suppose one hypothetical parabola. Okay, and suppose also que open to the right. Important, super important points. and segment and lines that you need to find. The first one, que is the most important, is this. This guy is called vertex. Okay, que is the singular of the thing that we discussed before in Elixir, era vertex. In plural vertex and singular vertex, only one. We have also one foci. Foci in plural, focus in singular. And focus lie in this axis. By the way, this axis is the axis of symmetry. Okay, because it's logical, no? Split the parabola into equal parts. Split the parabola is axis of symmetry. The focus always lie on the axis of symmetry inside the parabola. You never see that situation. This is a parabola and focus outside. No, the focus is inside. Suppose the parabola open this is my focus. Suppose the parabola open this is my focus. The parabola open down is my focus. Always inside. Okay. Now, one more. This distance is P. P is the famous. Okay, suppose that this is the equation for this is y squared equal 4px, no? This P is that distance from the vertex to the focus. Or from the vertex to another line that is called a directrix. This line is called directrix. Directrix. And that distance is also P. Okay. So we have 2 points so far, 2. Vertex, focus. And we have 2 lines so far, okay, is axial symmetry and directrix. In this case, the equation for directrix is x equals something, no? X equals something. One number here that depends on the distance, no? You can verify geometrically, no? Entonces now, in order to complete the picture of the parabola, you need to find 2 more points. Que es called endpoint. Endpoints of focal diameter. What is the idea behind focal diameter? Focal diameter is the segment passing through the focus and parallel to the directrix, and you have 2 points here, bam, bam. And this point is called endpoint over the focal diameter. But this distance is 2p. And this distance is 2p. Therefore, the entire distance of the focal diameter is 4p. And this is the reason when the equation appears, you see 4p. Okay, another book. There are many possibilities to express this. The most popular is this, using 4p. Another book using A, but A complicated the thing, AX. Because the focal distance would be 4p equal A. Okay, this is weird. I don't like this way. Okay, so now you find, so this give me the information how wider is my parabola. See, the focal diameter is bigger. It's because, how narrow is our parabola. Okay. Let's see example. 1, 2, 3, 4 example of the parabola. Okay, let me start for the easy elementary. Of course, we are using the script in Desmos I created for you. And that's it. Any question about the important information that we need to plot in the parabola? No? Okay. Okay, no. Suppose example 1 of the parabola. Example 1 of the parabola is x squared equal ay. Uy, esa parábola. How do you know que es parábola? Bueno, I know because I can see x squared and y no square. Okay, si I see x squared and y squared, maybe it's ellipse or hyperbola. After I want to explain the hyperbola in detail. Pero no square. Why no square? Therefore, it's parabola. Identification. Wow, it's parabola. What kind is? We have 4 possibilities. This parabola, this parabola, this parabola, or this parabola. ¿Es horizontal o es vertical? $50-50. Es vertical. Because I know by memory que cuando x is squared es vertical. Okay, super. Entonces, so far the information that we have is parábola es vertical. To determine in what direction opens, is down or up, we compare with the equation, okay, you know, x squared equals 4p, y, entonces I can see clear like water, que 4p is 8. I copy one corner of the piece of paper, 4p equals 8, therefore p is 2. And to the positive, that means that this parabola is vertical and open up. Open up. So far, everyone follow me? What about, in this case, have no sense to talking about center? No. The parabola have no center. The parabola have vertex. And the vertex is located at the point 0, 0. In general, this equation for any situation is x minus h squared equal 4p y minus k. Okay, this is the equation of the one vertical parabola, of course, but the vertex is located at the point h, k. In this case, the vertex is located at the point h, k. In this case, no. It's 0, 0 because I don't see any shift, horizontal or vertical shift. No. Okay. I know que P is 2. So it's open over. Okay, now I need to determine foci or focus, sorry, only one, and end point of the focal diameter. I have one nice idea how it look like the parabola. Let's do it by hand, and after we check it with the script and this one. Okay. So our parabola. The center is in 0, 0. The center, no, the vertex, sorry. The focus is the same distance. You open up. Now the focus is located at the point 0, 2. It's obvious, right? Because P is 2. This is my focus. And the focal diameter point is 2p, 2p. 2p, 2p. Entonces 2p, 2p. 2p in that direction, 2p in that direction. Entonces, si p es 2, 2p is 4, no? And 4p is 8, exactly the original number that we have in the equation. But I don't care. I care p, 2p. 2p is 4, entonces 1, 2, 3, 4. That point is the point 4, 2. And the opposite direction here is -4, 2. Boom. And this is my parabola. My parabola look like similar to this. Let me try to do my best. Remember, this conic section are a smooth curve. It's completely wrong. Try to do one parabola like that. Boom, boom. No, this corner is illegal. It's a smooth curve. Okay. Now, of course, it's super symmetric. Super symmetric. I am doing wrong, as always, but that is a reason that Desmo is our friend to help me to understand this. But don't forget, very important, very important, very important. This is the axis of symmetry. Axis of symmetry is a vertical line, x equals 0 in this example. And the directrix is the same distance que 2, here 2. Directrix in this case is horizontal line. And the equation for the directrix line is y equal -2. This is directrix line. End the story. Cool? Moving on to decimal to see more clear, because this is a mess idea in the piece of paper, no good. Now let me try. Do you see decimals? Okay, let me delete that part. Let me put unenable that part. And move on to example 1 of the parabola. Example 1 parabola is this. X squared AY. Oh, look at that parabola. Uy. Bueno, at least I understand que es vertical and open up. At least. Now, you fix it now P. P in our example is 2, no? P in our example is 2. Move the slider or you type it directly on the parameter 2. Okay. Okay. And the center, no center, sorry. Vertex is located at the point 0, 0. So H and K both are 0, 0. H 0K. P2. And we are talking about vertical, no? Vertical parabola. Yeah. Boom. Look at that. This is my vertex. This is my focus. This is my endpoint of the focal diameter. This is the directrix, this line. And this is my axis of symmetry. Any question, guys? Let me go 1 minute to the 1 second, 2 seconds to the restroom. Okay, I'm back. Do you follow me? It's okay or no? Whiteboard. Okay, okay. Let's do one more. I have 4 examples. Remember, complication in different positions. Some example you need to complete the square or another no. It's obvious. trivial. Another is complicated. You see whiteboard, right? Okay, good. Now, example 2 of the parabola is y squared equal 16x. What is that? It's a parabola, right? And remember, we discussed parabola. It's obvious because parabola, because I don't want to explain another thing now. However, when you in your problems, no specification, so you need to understand the characteristic. Characteristic is si y es square and x is no square. Oh, entonces parábola. Si y es square and x is square, entonces no parábola. Maybe es, bueno, depende si es plus o es minus. Si es plus, es ellipse. Let me anticipate something. And si es minus, is hyperbola. I want to study in few minutes. Okay, entonces now one square and y another no square. It's obvious que es parabola. And this parabola is vertical or horizontal. Remember, we have 4 kinds of parabola. We have this, or this. Horizontal, vertical. What do you think? Horizontal or vertical? Yeah, horizontal. Ahora, to determine in what direction open, si es right or left. Es right or left. Entonces you take the equation que es y squared equal 4px and you put equal each other 4p and 16. The 4p is equal to 16 divided by 4 both sides, p is 4. And 4 is positive, entonces es obvio que hago parábola open to the right. Open to the right. One more time happen, get the vertex. Be familiar, guys, with the terminology, not center, vertex. It's located at 0, 0 because I don't see any shift. And P is 4. So now I'm going to find, let me try to do by hand first. And after, the answer of the question is always do the graph. Okay, so it's 0, 0 is the vertex. Let me enlarge. Okay, there you go. 0, 0 is the vertex. One more information we need, one of the foci, or the focus. The focus, the distance is 4. Remember, P is 4 in this example. Positive. Entonces the focus is located in 4. 4, 0. Remember, our parabola look like that. This is the vertex, 0, 0. The focus is here. 4 here. 4, 0, 0, 0 vertex, 4, 0 focus. Okay, cool. Entonces, I open arbitrary here? No. No, because I need to find the endpoint of the focal diameter. Endpoint of focal diameter. Endpoint of the focal diameter. Remember, it's 2p, 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 2p. P is 4, 4 times 2 is 8. And that direction 8, is 2. No, es, a ver, let me see. It's 8, yeah. Well, A is 6, 7, 8. I suppose it's out again here. And the 8 here. It's too wider parabola. This point is a point 4,8. And this point is a point 4,8. You see in decimals now. And the parabola look like that. Oh, sorry, my trask is not good. This distance is 8. Why I know it's 8? Because it's 2p, it's 8. 2p is 8. And 8 in the opposite direction. One more information, one axial symmetry is so big as this. que split the parabola into equal parts. The axis of symmetry is, the equation is y equals 0, no? And the directrix is a -4 because P is 4, entonces es -4. Directrix, I suppose, using my imagination, okay, it's like that. Boom, 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 boom. It's the line x equal -4, directrix. Okay. Let me try to see in Desmos. Do you remember to see this in high school? At least one time in your life, or never you see that? Do you see that in high school? No. Wow. Unbelievable. Okay, so now in our example number 2 of the es 2, no? No, es 2, yeah, es 2. P is 4, no? P is 4. Okay, let me delete that part because it's horizontal. No. Let me delete that. And this is important in calculus, guys. Example 2 is this. Look at that. It's a big, wider parabola. The parabola look like a satellite dish, no? Of the TV. Okay, so now P4. Let me move P4. 4. There you go. And the center is always 0, 0, no? And you select now the horizontal, no? Horizontal parabola, right? Horizontal parabola. Ah, look at that. Look at that. Let me make a zoom. Vertex 0, 0. Focus 4,0. Endpoint of the focal diameter 4,8, 4, negative. And the axis of symmetry is the line que coincident with the x-axis, que es y equals 0. And the directrix is x equal -4. You see -5, -1, -1, -1, no. -1, -1, -2, -3, -4, and -4. Cool? Any question? To do the graph, always using this, okay? This is great, okay, great for my students. Let's do a number 3 example of the parabola. Okay. Now whiteboard. You see, right? Example 3. Example 3 of parabola is y plus 3 squared equal -4 x minus 2. Well, in this case, the only complication that I introduced here was, okay, I put it the translation, no? O sea, horizontal shift, vertical shift, no? Es obvio that the vertex of this parabola is located at the point 2, -3, correct? These two is these two. You see, all you need to remember, that when the equation you see minus, it's positive. And this 3 is this, and when you see that the equation is positive, it's negative. Entonces, now, in what direction open? ¿Es vertical o es horizontal? Okay, the famous question is vertical or horizontal? Yeah, absolutely, es horizontal. Es horizontal. Because y is square. So we have horizontal, entonces horizontal we have 50-50, two possibilities, right and left. And that depending the control of this is the P. Es obvio compare this equation and this equation, and the equation that I have in my mind is y minus k squared is equal for P x minus h. That is the reason that h is 2, k is -3, and for P is equal -4. Sure. For P is equal -4, therefore P is -1. Si es -1, es obvio que agua para abajo, open to the left. Do you follow me? Okay, so basically it's to the left. It's to the left. The vertex is in 2, -3. P is -1, so actually it's 1P in distance, but to the left. And the endpoint of the focal diameter, well, we can determine. Similar, no? Entonces now let's put in decimals to understand more clear the example 3. Example 3 is, we try. Okay. That was example 2. Okay. Now example 3. Look at example 3. Example 3 is y plus 3 squared equal -4, parentheses x minus 2. And the graph look like that. Boom. Boom. Okay. is the horizontal parabola open to the left. Okay. So what about the confirmation? The confirmation is P. I don't care A and B. No, P no important. The important is H and K. H is 2 and K is -3. -3. Okay. And what kind? And P is -1, no? P is -1. -1. And what is the category that we select? This is horizontal, no? Parabola, I suppose. Let me see. Bam. And you see, okay, the vertex 2, -3. Let me make it zoom. The focus is 1, -3 because the distance is 1. Of course, 1 to the left. Okay, now subtracting the component, no, is 2 minus 1 is 1, and the y component stays the same because the motion is horizontal, no? And the endpoint is 2p, upward and downward, 2p. Si es 2p, que 2p es igual to 2, ¿no? Entonces, -3 plus 2 es -1, and -3 minus 2 is -5. Likewise, we have here the line that represents the axis of symmetry and the line that represents directrix, que es the vertical line at x equal 3. Es obvio because it's always h value. Si h value es 3 o es -3. A ver, let me see. Yeah. Entonces es 3 positive. A ver, let me see. Something is weird. No. A ver, es 2, sorry. 2 positive. Plus 1 is 3. Yeah. 3. The equation for directrix is x equal 3. And the equation for the axis of symmetry is y equal -3. Okay. And do it well or no? Why make a mistake? And do it well so far. Okay. Let me try one more example for the parabola. complicated. Okay, we need to complete the square something. Okay. 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 There you go. Example 4 of parabola. Look at that. Is 4x squared minus 20x minus ay plus 57 equal to 0. This is like general. But I recognize, wow, it's a parabola because we have x squared and y no squared. Entonces es obvio, at least in my mind, that we are talking about vertical parabola. I don't know if you open up or open down. Okay, so the equation I need to transform it is, my goal is this, is x minus h squared is equal 4p y minus k. Definitely, I need to move y to the right hand side, and x stay in the left, but I need to complete the square. To complete the square, okay, you take this and this together, and this and that, I move into the other side maybe. Okay, so one first step is 4, I can factor out, why not? 4x squared minus 5x plus a box. Okay, complete the square. In the right hand side, I move ay minus 57, something like that, plus another box, no? Okay, not necessarily the same number here. So what is the I try to manipulate this equation and try to look like similar to this, no? Okay, now the magic number to complete the square is 555 divided by 2. I don't care the sign. You always divide by 2 and a square. It's obvious that 25 over 4. So you put it here inside the box 25 over 4. When you introduce artificially, because you need that, 25 over 4, and the other side you put just 25 because 25 over 4 multiplied by 4 cancel out the 4 is just 25. So in order to keep the equilibrium of the equation, you put only in the right hand side just 25. Okay. Now I want to factorization. How? Well, you copy 4, and this is a perfect square trinomial. This x is the square root of this guy, minus this minus is this, and this is square root, this is 5 over 3. Over this is 4, no? No 9. Hello. This is 4. Entonces 5 over 2, no? 5 over 2. So square root is square. Square root 25 over 4 is square root 25 over square root 4. This is 5 over 2. And 5 over 2, by the way, in decimal is 2.5. Maybe it's convenience to write in decimal. I don't know. Let me try. Let me continue the manipulation. The manipulation is 57 and 25 together. I suppose it's 32. Let me use my calculator. 57 minus 25 is, yeah, 32. So actually we have ay minus 32. Okay. We almost finished. No, not yet. Because remember in the formula we have coefficient 1 here. You divide by 4 both sides. By 4. Let's see. We almost finished. We have x minus, I like to put 2.5 is equivalent square. is equal to y minus a. Okay, if you factor out 2 outside, 2y minus 4. Okay, and now look like very, very similar to this. X minus 2.5 squared is equal to 2 times y minus 4. Let me copy and compare. We have x minus h squared equal 4p y minus k. Bueno, es obvio que this vertex of this parabola is located at the point 2.5, 4, right? 4. 2.5 is this guy, and 4 is this guy. And 4p is 2. Entonces p is equal to over 4, que es 1/2. It's small. And I predict que ese es a little bit, you know, it's open over because p is positive. This vertex is located at the point 2.5, 4, and this is a little bit narrow because it's 1/2, no? 1/2 in 1/2 times 2 is 1, 1 in this direction, 1 in another direction. Remember, the endpoint is 2p. Okay. And this is the analysis. Let's move to see more clear. Sometimes it's confusing, no? The number, but there is a reason I create this script to help my students, no? You are doing the analysis. The most important for me is this analysis, no? Complete the square, manipulate. Guys, this is just algebra. And to say now, unbelievable, it's true. This equation is equivalent 100% with this equation. So you are doing both and decimals, you see. No, actually, the thing we are doing is this. I copied exactly the original problem. I put in the equation, I put h and k and p. I plot that if they are perfect coincidence. Okay, let's do it. Switching. Boom. What number we're doing? Number 4, no? Number 4 is, okay, I put on enable this. Number 4 example. And number 4, no? And number 3 or number 4? Number 4. Number 4 is this. Look, I copy here. Oh, wow. Look, it's a parabola. Okay. Now I go here to confirmation. Parabola is, I determine que h is 2.5. Let me try to do my best. 2.5. Carajo. I'm typing. Oh, this is h and k is 4. Let's try 4, positive 4. No, it's a p, coño. 4. P is 1/2, it's 0.5. Okay, ready. We are ready. So now we are talking about vertical parabola. That one. Boom. You see it's narrow. Vertex, focus, endpoint focal diameter, directrix line, axial symmetry line. End story. Any question? So definitely you never see this in high school. Or in the high school you don't pay attention. Entonces you go to college, in college you learn, because you are adult. Okay, hyperbola now. Hyperbola, let me explain hyperbola in details. Hyperbola now. Let me explain hyperbola in detail. Number one, hyperbola contains two branches. And we have two kinds of hyperbola. Okay, hyperbola theoretical part. We have, this is the X and Y axis. And this is X and Y axis. We have two kinds. We have the hyperbola. Hyperbola have two branches, guys. Suppose like that. Or like that. Entonces now you identify, because, well, we have, let me explain in detail. We have center, very similar to the ellipse. In parabola, no. In hyperbola, yes. And this is H, K. Like that, H, K. Entonces, what is the clue of the identification hyperbola? This is horizontal, this is vertical. Well, when you have the hyperbola like that, x squared over a squared minus y squared over b squared equal 1. So you have x squared and y squared, but now it's minus a hyperbola. It's the identification. But to differentiate in between horizontal and vertical, you have, for example, here y squared over a squared minus x squared over b squared. Professor, this is weird. Yeah, because the habit that we have in the ellipse, identification in the ellipse, you associate A is the big one. No. Now A now in the hyperbola is always the positive guy. We have positive and negative. The positive is A. It doesn't matter if it's smaller or no. It's not important. It's totally irrelevant. The important information, the positive guys, the coefficients associated with the positive part is A. And the coefficients in the negative part is B. And that means that the transversal axis, this is a new concept that you need to understand very well. Transversal axis is the axis, in this case, is like that, boom, 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 is parallel or coincident with the x-axis. That the positive part immediately define the transversal axis. In this case, no. In this case, the transversal axis is like that, boom, 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 boom. We have another axis, but it's not important. The transversal is the central idea. And also another important thing in the hyperbola, C, que es the focal distance. It's different equation. So the equation that you normally using in the ellipse, forget about this. It's another equation. It's another relationship between A, B, C. Is C squared is equal A squared plus B squared. And the ellipse was A squared equal B squared plus C squared. This is for ellipse. Now forget about ellipse. Now it's different. To determine C is square root A squared plus B squared. And entonces C is the bigger guy, is the bigger segment, is the bigger distance, the focal distance. And the focal distance is outside, similar a little bit to parabola here. This distance is C. This distance is A. This distance is A. Suppose the foci, by the way, we have two. Foci 1, foci 2 is C. And what about B? I don't see, Professor. This is C. Well, to see B, you need to understand a little bit more clear the hyperbola. Let me explain example of the hyperbola again. To don't complicate the thing, I want to do again two rectangular coordinate systems. We are talking about horizontal, we are talking about vertical. It's obvious in this case the axis transversal is like that. In this case the axis transversal looks like that. Now our A is here, minus A. This is the vertex. And the vertex is here and here. A and minus A. What about B? B is another quantity que no necessarily is smaller. Remember, the definition of the A is that the A is the coefficient in the positive part of the hyperbola, but B is the negative part, but I don't care. The sign is not important. B is another segment que is here. B and B, minus B. Entonces, in this case, this is B, and this is minus B. And we form now a rectangular. And this rectangular is called in the book reference. Rectangle. Okay, we have rectangle, okay, no problem. And you join the corner of the rectangle in that way, passing through the center. Here, exactly the same. Passing through the center, guys. And this is the asymptote. This is the line asymptote, any hyperbola have. But to do the graph approximately, not approximately, only good approximation, the hyperbola passing through the vertex and asymptotically to this asymptote. The other branch passing through the vertex asymptotically to this. Okay, and here similar, passing through the vertex asymptotically to this. And here passing through the other vertex asymptotically to this. And by the way, the equations of the asymptote are y is equal plus or minus, because we have two, no? One is low positive, one is low negative, b over 8. Look at b is like a rise and wrong x. And here is different, is plus or minus a over b x. But this is the supposition that the center is in the origin 0,0. When the center is not in the 0,0, entonces the equation of the asymptote I modify a little bit like that. Y minus k is equal plus or minus b over a is the slope x minus h. And here y minus k is equal plus or minus a over b x minus h. Boom. Okay. Ready to start example. This is the theoretical part. We have different terminology. The first new thing we see is axial transversal. Secondly is a reference rectangle. Okay. And the asymptote. Okay. Let's move into the first example of the hyperbola. Example 1 hyperbola. Easy, like any first example is x squared over 4 minus y squared over 9 equal 1. My question is hyperbola? Of course, it's hyperbola because I see x squared and y squared, pero minus in between them. Si es plus, es el x. En parábola no. Parábola, we have one square and another no square. Okay, now identification. What kind of the hyperbola we have? We have that one or that one. This is horizontal, this is vertical. How you recognize? Using your eyes, no algebra. Eyes, use eyes. Horizontal, yes. Because the axis of transversal is like that. Because the positive part is associated with x. Okay? This is when you have this situation is when the y is positive. But no, in this example. Okay, es horizontal. Okay. Entonces, who is a square and who is b square in this example? Please, help me. So you select two numbers, no? We have 4 and 9. Who is a square and who is b square? A is a square 4 and b square 9. Because you take a like a positive part. Always keep in mind, a is positive, b is negative. Therefore, a is 2 and b is 3. And what about c? Well, c is square root a squared plus b squared. It's the square root 4 plus 9, 13. And square root 13 is approximately irrational number 3.6. Those are the four c's. So this time, let me do a roughly sketch. I know. Okay, mine. Roughly. After we see this, my graphic look like that, no? That distance is 2. That distance is the 4C is 3.6, right? And the reference rectangle you form using 3 and 2, no? Entonces 3 here, 3. This distance is 3. And we connecting reference rectangular. And the corner of this is the asymptote. Curve passing through the center, que by the way, I forgot to say que es 0, 0, no? Because we have no shift. Okay, cool. One more information. Information for the asymptote is CC is y equal plus and minus b over a, b is 3 over 2. Remember, it's easy to remember because it's rise is 3, wrong is 2. X is the equation for the two asymptotes. Well, positive is this. And negative is this. Okay? It's no big deal. I'm using the script of demo is easier. Also. Let me try to show you. Okay. Wow. You're supposed to get the last problem we are doing now. Yeah. Es Desmos. Okay. No, here. Okay, let me unlabel this. Okay, it's hyperbola, no? Hyperbola, example 1 is this. Look. Wow. Look at the hyperbola. When you put equation, you see the hyperbola. So it's solving the horizontal, but without any detail, no detail. A is 2. Let me delete that part, it's square root 7, 2. And B is 3. And H and K are 0, 0. 0, 0. Center at the origin. I don't care P. because P is always for the parabola, no? And we are talking about horizontal hyperbola, no? Boom, look at that. We have the center 0, 0 in green color. We have the vertex in 2,0 and minus 2,0 because A is 2. We have the famous rectangular reference, okay, the height is 3, and we connect in the corner, and we have the two asymptote. Look how the hyperbola approach it, but never touch the asymptote. You see? Look. Basically, the foci is at the radical 13, que es 3.6 approximately. Okay, it's out. Geometric is clear, right? Do you see that? Entonces now next time we are doing 2 more problems for the hyperbola, and we start new section. We almost finished, guys. We have a sequence, we have mathematical induction and binomial theorem, and that's it. I suppose I finished everything, I suppose. Okay. The problem was the holiday, no? It's okay. Okay. Entonces, have a nice, good day, guys. Nice days. We see Wednesday. Bye.